Welcome to our third webcast from Preston New Road, the site of Cuadrilla's shale gas exploration site. It's a unique location in the country because Cuadrilla are drilling horizontally into the shale rock. Cuadrilla are a Lancashire-based company specialising in the search for the hydrocarbons we all need to keep our homes warm and industry going. Cuadrilla believe that 3.5 kilometres beneath my feet here are trillions of cubic feet of shale gas that's been trapped in the earth for millions of years. On our previous webcast, we've looked around the site to see all the equipment on the surface, and in the last webcast, we looked at coring. Today, our subject is drilling. So if you've got any questions, you can enter them in the webcast chat box. Details of that are at the bottom of the screen. Now, our guide for today is going to be Laura Hughes. She's Cuadrilla's commercial and supply manager, but vastly experienced in the whole question of drilling, and we'll come on to that in a moment, Laura. But first of all, let's talk about women and engineers. Far too few of them, aren't there?
No, absolutely. We are very underrepresented in the industry. I think there's less than 10% of registered professional engineers are women in the UK. We're lagging way behind our European neighbours, where in some middle European countries up to 35 or 40% of engineers, registered engineers, are women. So yes, we've got some way to go, and it's very important for our industry that we do keep tackling that problem. So
why do you think there are so few women engineers?
I think that it's very easy for people to follow down routes that suit the stereotypes that we see on TV, that we see in schools, and I think that there's not enough challenging of those stereotypes to really tap into what people's true strengths are to get them into the professions, and in this particular one, get them into the engineering.
There's stereotypes that engineering isn't for women because it sort of can be a bit sort of muddy and rough and that sort of thing. Is that a stereotype you're talking about?
Well, I think there is a bit of that. I think there's also a bit about not really appreciating and understanding the true scope of what engineering is about the creative part of it, about the problem solving, about the exciting things that you get to tackle. And I think that it's seen as quite staid and quite boring and not very inspiring, and nothing could be further from the truth.
Absolutely not, and we're here right at the frontier of it all, right here. But to try and get a bit of a picture of all this, let's talk about you. I mean, did you get an interest in it when you were at school?
So I enjoyed sciences at school. I enjoyed maths. I enjoyed the creative stuff. That inspired me. My dad was an engineer as well, so I was very lucky that I had the opportunity to see what he was doing and to work outside on vehicles and cars and fixing stuff on the farm. So I got a flavour both for the science of it and for the practical.
And then you, when you finished at university, you went and worked for Shell?
Yes, that's right. Many of the oil and gas majors have very formalised training programmes, and I was very lucky to get onto Shell's well engineering training programme, and that's where I learnt my trade.
And then you came up to the northwest? You now live here in Lancashire?
Yes, absolutely. My career is taking me across the globe. Drilling and exploring and developing oil and gas across the globe, and absolutely I'm delighted to be back here in the north of England, putting my skills to practice to make it a reality here.
That's quite interesting. So you have been all over the world, because a lot of youngsters want to sort of see the world, so you'd recommend an engineering career in order to do that? Oh,
absolutely. I mean, if you like that technical challenge, you like to be creative, you want some adventure, then there's nothing better than this industry and nothing better than engineering.
Where have you been?
So I started in Egypt. I've been in Brazil, both drilling in deep water, so in over 1,500 metres of water on very highly sophisticated floating rigs. I then moved to Gabon in West Africa, where we were drilling in the jungle of Gabon in a land operation, very similar to this one. And I then moved to Uganda, and right at the frontier of oil industry in that country, drilling in the hinterland of Africa. Yes.
How interesting. Well, we could talk forever about that, Laura, but we need to move on because our job today is to look at this drilling, and I think we'll get a better idea about what's going on in that respect if we now go to the core lab.
Yes.
Here we are in the core lab, and people who watched our previous webcast will remember that we were here before But what wasn't here was this core, Laura, that's come up from the earth in the last 24 hours?
Yes, absolutely. So since you were last here with Hugh, we've started our coring operation. We've cut several tens of metres of core through the Boland shales, which are the interesting formations that we're looking to find gas in. And absolutely, this is part of the core that's come out overnight from one of those sections. So it's fabulous, really, that this is the first really exciting piece of data that we're getting out of these wells, taking these samples of the formation that we need to understand better.
So this is Boland shale rock?
Absolutely, this is Boland shale rock.
And
Yes.
I'm looking at it here. I see these markings here. What are the significance of them?
So these are the natural fractures that are in the rock. When it was first laid down, it was that continuous marine deposit that Hugh was talking about. But over geological time, it's been scrunched up and it's been twisted and it's been turned and it's been cracked. And then these are the deposits that have then made their way into those fractures. What we will be doing when we come to do the hydraulic fracturing is creating more fractures, a lot smaller than this, the ones that are mechanically imposed by us, but connecting these fractures together to create that connectivity between all the tiny little pockets of gas in the shale.
Now let's talk about those tiny little pockets of gas, because obviously we can't see them here, but in the next room here in the lab, we can actually see a core sample with bubbles coming off. How significant is that?
Well, we knew that there was gas in the shale. This is really just sort of seeing the proof and the repetition from what's gone before. But indeed, we can see the gas that's coming out of the shale when you submerge this in water. And we also have longer term testing whereby the gas that's coming off the shale is being collected and quantified, measured, both in terms of volume and in terms of the quality of the gas as well. And that's all going on next door.
So tell us a bit more about the testing. What are you actually going to do with these cores now?
So what we're interested in is we're interested in the actual mechanical rock itself. Because we need to understand how the fractures are going to spread through the rock, and we're interested in the quality of the gas, of the fluids. So we're going to be sending this away to some specialist laboratories, as well as doing some testing here ourselves. I think last time when you were talking to Hugh, he was showing you the plugging machine. So here they've obviously spent their time this morning cutting out some of those samples that can go away to their laboratories, and they'll continue to monitor the core that's here as well to see what happens with it over time.
And after that, of course, you're going to get into the serious business of horizontal drilling.
Yes, well, so we'll cut the core and we'll finish off this pilot hole, this kind of test hole through the Boland shale. We'll then collate wireline logs, so that's tools that instead of going in on the drill pipe, go in on a wire, and they will be looking at what we see on the outside of the hole that this core has come out of. So we'll be looking at properties that the rock actually has, we'll be looking at the dip of the rock, we'll be gathering information about the hole. And then what we do is we plug that back with cement. We don't need to use that vertical hole anymore, and then we start the serious business of placing the horizontal drains.
And safety, of course, is absolutely uppermost in this whole business. So we're now going to go and look at some of the equipment that's going to ensure that all this is done with the maximum safety in mind.
Absolutely.
The last time we were here, this large piece of safety equipment wasn't here, and Laura's going to tell us its purpose.
This is the blowout preventer. I think when you toured the rig with Eric previously, it wasn't here because we were still drilling in the shallow formations where there's no chance of hydrocarbons. But now that we're down in the reservoir formations where there is gas, we need to make sure that all the barriers in place to make sure that the gas doesn't flow to surface at the moment.
Yes, we need to be clear that, of course, eventually we do want the gas to flow to the surface, but not at the moment.
Absolutely. So for the moment, the drilling operations and then the fracturing and completions operations are conducted without any of the reservoir fluids coming to surface. It's only when we start the well testing operations that we'll be able to bring gas up in a controlled fashion. But for now, the fluids stay where they've been for many millions of years.
Of course, the chances of gas coming up are very small because they are tiny bubbles in that shale rock.
Yeah, absolutely. I mean, the fact that this is a shale rock that needs fracturing in order to give us the connectivity to allow the gas to flow means precisely that the chances of gas coming to surface are very, very low. but we have all the barriers in place anyway that are very standard within our industry.
You were mentioning Eric, and we remember on our first webcast he showed us all the mud coming up, and that was dealing with the lubricating the well and removing rock debris, but mud has another function at this stage of the exercise.
Yeah, that's right. The drilling fluid, the mud, is designed so that the pressure in the column of the liquid matches the pressure of the gas in the formation. So you use the hydrostatic, use the weight of the fluid to balance the pressure between your wellbore and the formation so that the gas can't come up. And that's our primary barrier against flow at this stage.
And going back to the preventer, I can see two sort of screw-like things halfway up and another one at the bottom. What function do they fulfill?
So the blowout preventer is the secondary barrier. So if for some reason that things didn't go as planned and we needed to be able to close the well at surface, that's what this does. So starting from the bottom, as you say, we've got we do have three things that have the square actuators. Those are valves that can close around the outside of the drilling pipe. The one at the bottom and the one at the top, they're called variable rams, and that means that they have ability to close very tightly around different sizes of pipe. And the one that you see in the middle there, that's a shear ram, and that can cut the pipe. So if for some reason you want to have a very definitive seal at surface, that can cut the pipe. And the one that you see at the top, that's called an annual preventer, which is actually a bag that we inflate with hydraulic fluid around the pipe, again to give you a very tight seal around the outside of the pipe if you need to do that in the operation.
So we've got all this safety equipment, but obviously it's operated by human beings who need to be trained. Just tell us something about this safety training that people have to go through here.
Yeah, exactly. Our safety system is made up of training, it's made up of procedures, and it's made up of the equipment. So even if you're just a visitor on site, as you are today, you go through a safety induction so that you understand where you can go on the site, you understand the precautions that you need to take. But almost more critically, I suppose, is that the people who are in charge of the operation, either people who have general oversight like the drilling supervisors or people who have really specialist roles, are all trained to a very recognised standard. So within our industry, there are a number of international bodies who are recognised across the world as setting the standard for that training. And everybody who has a safety critical role will have been trained on those courses. They're normally repeated every couple of years or so that everybody's training is right up to date. We've got evidence of everybody's certification of their level of competency, and that we know that everybody is able to execute their job. And then we as the operator, with the subcontractors, we have the safety management system, and so all the work that we conduct is in accordance with that safety management system.
Laura, thank you very much indeed. That was all very informative.
Thank you.
Well, having looked at the blowout preventer, Laura and I are now here to answer your questions. They've been coming in as we've been speaking, and thank you very much for them. Keep them coming in. And Laura, the first question is actually from Kathy, and she says, how many people are currently working on their site, and what are they up to?
So we've got probably about 30 people or so on the site at the moment. That's made up of quadrilla people and key contractors who conduct their specialist services for us. We've got people who are actually working on the well itself, so the guys up on the drill floor who are actually conducting the drilling operation. Then we have the people who are down here on the ground who are preparing for the next phases of the operations. We've got our geologists and technical specialists in the various units who are then looking at the information and understanding what we're seeing in the well.
Okay, now the next question is from Trina, and she's asking about the amount of gas in the shale. Is it consistent, or are there areas where there's greater amounts of gas?
So the Bolland Shale, as we were saying earlier, is about 1,000 metres thick. And it's not uniform at all. It was laid down over a long period of geological time under different conditions, and so that it's really lots of very, very thin layers that are all then compressed together. So we're expecting both the gas to change as you go through the shale, and also different geologies as we're going down. And so exactly what we're looking for is to see where the sweet spots are in that shale reservoir, where we would want to place our horizontal drains.
The next question, and we're getting a lot of questions from women, and in light of our conversation earlier, it's very appropriate, this. And this is from Kate, and she's asking about the prospects of you doing another seismic survey. Why do you need to do that? Because you've already done one, haven't you?
Yes, that's right. So this area is covered by a 3D seismic survey that we shot a few years ago. And it was from the data that we'd gathered from that survey that indicated that this place, where we're standing here, would be a good place to put a well. A seismic survey is where we have a sound wave that starts at surface and then reflects off these various layers in the subsurface formation, and then we have sensors back at surface that measure that. So of course it's measuring time, it's measuring how long it takes a sound wave to get from the source to the receptor. And what we do is that we convert that time into a depth measurement using what we know about the rock. Now that we've got the pilot hole being drilled here, we've got actual data from the actual rock in the right location. So what we do is almost like a mini seismic, so that we measure the sound travelling from the surface down to a receptor in the well, and then what we can do is use that information to better calibrate and to refine our understanding of the 3D seismic, to be able to even more accurately place the drain. So it's a way of starting to tie the information together.
Now, you wear a number of hats, and amongst them being you're the Quadrilla's Director of Commercial and the Supply Chain. So we've got a question that's come in here. How many contracts have you signed with Lancashire companies so far?
Oh, we have probably... sorry.
And particularly, how much money have you invested in Lancashire companies?
Oh, right. So since the beginning of our operation here, we've spent over £5 million with Lancashire-based businesses, and that's supporting us in all sorts of ways, with transportation, with water management, with supply of clothing, for example, the PPE that we're wearing today. And we've got, I don't know the exact number, probably between 20 and 30 local suppliers who are active in our business at the moment. We primarily start with the local supply opportunities when we're looking to buy something in support of our operation. And we have a supplier portal, which is an online database where any business can register if they're interested in supplying their service or their product to our business. And we have over 600 companies registered on that database. It's growing daily, and we always go there first to see whether local businesses can supply what we need. And only when we're really convinced that it's not available here in Lancashire that we go further afield.
Another question, I think it's obviously from somebody who potentially would want to work with you. I mean, how easy? I mean, you've illustrated it a little bit, but just answer me again for this question. How easy is it to work with Quadrilla if you're a local firm in Lancashire?
So the first step is that you should register on the supplier portal, and there are links to that on our website, and if you put it in a search engine on the website, you'll easily find your way there. And what we're interested in is what the goods and services are that a company can provide, and then some basic information about the way that they run their business and their systems and processes. And then, as I say, we will always look to local businesses first. In order to work with Quadrilla, what we need to do is we need to make sure that the standards and the process within a company means that we've got good assurance of the quality and the way in which they provide their service or they look after their people, for example. So there is a process by which we start to understand more about a company. That's through a dialogue or filling in questionnaires, things like that, understanding their health and safety systems, for example. And then we start to discuss and negotiate around the scope of the supply and the rates. For most of the products and services we need, we do that through a tendering process. So we'll invite a number of companies to make an offer to us, and then they're evaluated on a very transparent and very fair way between the different companies who would like to do business with us.
We've now got quite a central question, really, and it is phrased in this particular way. When is the first gas going to flow, and when are we going to be able to enjoy our own gas rather than having to import it?
Oh, well, so those are two different questions. So as part of our testing operation, we'll be bringing gas to surface towards the middle of next year, and that'll help us to understand how the gas is going to flow out of the reservoir. The path then between this exploration operation and then future production, that's a lot longer scale, and it's difficult to say now exactly how long that will take. But at the moment we've got planning permission and the consents to drill 4 wells from this site. Those 4 wells will happen first, and then longer term, we look at how the gas can then start to give us a credible alternative to importing gas from Europe.
The next question is right central to your speciality. I mean, how is the drilling going? How deep have you gone so far? That's the next question.
So we're in the Boland Shale now, and as you say, you said previously, the top of the Boland Shale is about 2 kilometres below our feet. So we've drilled now most of the way through that Boland Shale. We've been coring, so we've been taking samples of that rock as we've been going along. So the drilling is going very well. We're getting the data that we need. We're getting the information that we need from the well, and then that's precisely why we're conducting this operation. And
I think this is really a follow-on question to that. I mean, how does the geology affect where you'd actually decide to drill horizontally?
So the Boland Shale, yes, it's got these interbedded layers. So you could say it's like a stack of pancakes, and we need to decide exactly which pancake it is that we want to put our well into, and that will depend on the mechanical qualities of the rock, and it'll depend on the quality of the gas that we see within the formation. So it's absolutely all about the geology. So the geologists are looking at the data that we're gathering, and then they'll tell the drillers this is the place in which we want to start our horizontal drain.
Alistair's asking why the Boland Shale is so attractive to you in terms of shale gas.
Well, there has been no shale gas production in the UK to date, of course. So we're really in the early stages of understanding which shale formations, which formations are going to be the most prospective, the ones that can give us the best chance of good quality gas production. The Boland Shale has various mechanical properties that are similar to perhaps what they've seen in the US and in some of the North American shale plays that have proved to be very successful. The Boland Shale has many of the same properties, and so this is a good place to start.
Somebody's been watching our particular section on the blowout preventer, and they're asking, why do you need a blowout preventer when you've actually said that the danger of gas coming up in any large quantities is very low?
Yeah, so as I said, this is an inherently low pressure formation. There's very little ability for the gas to flow through the shale naturally without us then fracturing to create that network. But there is no precaution that we shouldn't take. So even though it's practically impossible, we still put in place all of the standard measures that you would in a drilling operation. So we've got the hydrostatic pressure that the mud column gives us. We've got all of the casings and all the construction of the well, which are the barriers between the subsurface formation and ourselves. And the blowout preventer is just a completely standard piece of equipment that we would always use on every well.
Obviously, there is concern about safety, and another question, I think you just need to emphasise this, what other safety measures are in place?
So we have mechanical barriers, like the drilling fluid, like the casings, like the blowout preventer. We have then procedural barriers, so we have a safety management system that describes the way in which we work, the way in which we approach the operations, the way in which we validate and check and make decisions around our operations. And then we have the training component. We have to make sure that we've got the right people working on the site making the right decisions. So the people who are in key positions, they are trained to internationally recognised standards. They have to keep doing their exams very regularly, so they're always kept up to date with the latest knowledge and the latest approaches. So it's, I guess, those three arms really, the physical barriers, the procedural ones, and then the training aspects.
Laura, thank you very much indeed. Keep your questions coming in. We'll be having another section of questions to Laura, but now we're off to see a little bit more about horizontal drilling. Here we are in front of our huge canvas showing all the various layers of rock that are being drilled through. It was used by our geologist Hugh Clark in our last webcast in order to illustrate what's going on. But what does it mean to a quadrilla driller, Laura?
So yes, Hugh talked to you about the different ages of the formations and the fossil and the geology. What I'm interested in as a driller is how I can get from surface to the target formations. So understanding what each of the different layers means in terms of the rock strength and in terms of how best to tackle that from a drilling perspective. Now, if you remember talking to Eric, this well started off at surface, probably 30 inches in diameter, and by the time we get down to the target formation, we're just about 6 inches, or in fact sometimes less.
This is the diameter of the
pipe, of the hole, and then of the pipe. So this is really just very illustrative, of course, because the well is much smaller relative to the thickness of the formations as we see here, but it's able to show you how we're connecting the surface down to the target formation.
Just tell me a little bit about the history of horizontal drilling. It comes from the United States in the slightly less regulated era when they were first discovering oil.
Well, it was by accident, really. Wells were vertical, always vertical in the early days, as you could expect. They drilled holes down and drained the fluids. But actually, in the 1920s, when the industry was just taking hold and they had a system of leases, there were quite a number of court cases where one driller was alleging that somebody else was stealing their oil, and they started to look at the fact that the wells in fact weren't going vertically down but were crossing the lease line. So that's when they started doing this directional drilling, really by accident.
Well, we're not aware of any rogue operators trying to take your gas, Laura, but let me ask you a fundamental question about this. I mean, why horizontal drilling?
Well, I think there's two main reasons. It really started getting developed properly in the 1970s in the offshore in the North Sea, when they didn't want to be putting up one single platform for every single well that they were going to be drilling. So it made sense to have all of the well heads, all of the top of the wells together on a single platform, and then to be able to access different parts of the same reservoir from that one central point. So for us here in Lancashire, the idea is that you would just need one location and be able to drain a very wide area from the subsurface. So it really limits the surface impact that we have. On the other side is, and I suppose it comes back to one of the other simplifications on the lovely canvas, the Boland shale is not just one thick continuous shale. There are lots of layers in that came from the way that it was laid down, but there are going to be certain zones where the gas is more mobile and it is more productive, and so actually what we want to be doing is targeting those zones in the reservoir. So rather than poking one hole through a pancake and just getting access to that small area, this is about driving the straw along through the pancake of interest within the shale formation.
Well, we can see that quite dramatic curve to the horizontal there. How do you actually do it?
Oh yes, it's really quite clever, and again it's a bit more subtle perhaps than the canvas would suggest.
We had to simplify, forgive us.
Yeah, but normally when we're drilling vertically, we're rotating with the top drive, the whole of the pipe is rotating and the bit rotates to the bottom. I think Eric mentioned to you, didn't he, about mud motors, a motor that's right by the bit, that the fluid being pumped through the string spins the bit independently of the pipe, and that motor then causes the bit to move a lot quicker than the surface pipe would rotate. Now what you can do is you can put a bend in that motor, and then by applying the weight of the string onto that bend, you create a turning effect at the bit. So if you imagine that the whole weight of the string is pushing down on that bent piece, and then the bit is being forced to the side or to the top of the hole, and that creates the inclination that we're looking for.
You're explaining this really well, but I think we can do it even better by actually going and looking at some of these tools.
Absolutely.
So here we are with the tools that are going to make the horizontal drilling possible, and we begin with the drill bits. Two there that look as if they're made of gold. I'm sure you're going to tell me, Laura, that's not the case. They haven't been underground, but this one clearly has.
Yes. We've used this 8.5-inch diameter bit to drill some of the hole that we're currently making, and that will go back in the ground again. It's made with a synthetic diamond cutters, which we're using to grind away and to cut away at the rock. And as you say, these aren't made of gold. They just look nice and shiny when they first come out of the box.
So what are they actually made of then?
Well, they're a synthetic metal-based alloy with then the diamond cutters on the outside.
Right, well now let's look at the pipes, and you talk about strings, and because this is strings of pipes, and we've got various ones around here. Talk us through these here, because these measurements, we better come down here, Laura, and look at these numbers and these measurements on the actual pipes themselves, because this is going to be vital for what you're going to tell us about. Yes,
absolutely. So right at the bottom of that drill string, we've got the mud motor. So this mud motor, I think Eric has described it to you before, it enables us to spin the bit independently of the main string. So when we're drilling vertically, the whole of the drill string is turning, but when we start to do our directional work, we want to hold the string still and we want the bit to be spinning. So inside this pipe, there is actually a spindle, which as you pump the mud down the pipe, that causes that spindle to rotate and it spins the bit that's on the end of it.
And so what are these markings here? What are the relevance of those?
Well, in order to start us moving away from vertical towards horizontal, we need to have a bend in the pipe so that we can sit the bend on the bottom of the hole and we can force the bit against the side of the string. And this is the point at which the motor can be set to have a bend. So what you're seeing, those markings there, is actually all of the different angles that we could set the motor to. This motor is straight, and this motor is bent already.
Well, you say it is bent, Laura, but it doesn't look bent to me. I mean, I'm struggling to understand how, because we've seen on that canvas, you know, how it's going down vertically and then suddenly it turns a corner. I don't see that sort of scale of bend in this pipe.
Absolutely, the canvas is really just showing us kind of diagrammatically. Actually, the reality is that the build-up is what we call it, the bend in the well, is very, very subtle, and therefore the bend that we need in the motor is also very small. So the bend on this motor is actually less than 1 degree. So if 90 degrees was a right angle, this is just slightly set to being off straight.
So that there is all that makes a difference?
Yes, so you can hardly see it unless you're looking down the length of the motor itself, but a small twist in the motor means that it's not straight anymore. So less than 1 degree, and that is enough, so that what you do is this plate here, this is the kick plate, that sits on the lower side of the well, that takes the weight of the string and then forces the bit up, and you might be causing a bend of maybe 2 or 3 degrees over every 30 metres. So it's a very, very slow build-up over hundreds and hundreds of metres of well length.
And just one more question on this. Aren't you losing power as you go down 3.5 kilometres from the surface?
So I think this is where the operation that we're doing here is different from if you were drilling a hole in the wall. So if you were drilling a hole in the wall, you'd be pushing in your drill, and the further you got through the wall, the harder work it would be. But as our drill string runs in the hole, it's a long and very heavy string of pipe. The push at the drill bit comes from the weight of the pipe rather than the top drive pushing down on the string. So even though you're very deep, you're relying on the length of the string and the weight in the string to give you the weight that you need and the push on the bit to really force it into the bottom of the hole.
Now we must move around here because we've got one other very, very important component of this horizontal drilling. This is what I describe as the technology end of things.
Yeah, absolutely. So this is the measurement while drilling the sub. So from the outside, it doesn't look too exciting. It's made of a different kind of steel, a stainless steel, rather than the normal steel that the rest of the string is made on. Because inside of here, there are a lot of very sophisticated electronics that are telling us exactly where the bit is.
And this is all done, and these are very, very tiny measurements?
Yes, absolutely. So in order to be able to know where exactly in space we are with the drill bit and remembering that this is several kilometres away from the rig itself. We need to know how long the string is, so how far away it is. We need to be able to measure the inclination, so how far off vertical it is, and we need to be able to measure the azimuth, so the degree from north. And with those three pieces of information, a computer could then triangulate exactly where the drill bit is. And so within here are the very small tools that are able to measure the inclination and the azimuth, and then they need to be able to get that information back to the surface.
You've explained it very well, but we have got a video just to remind people of the whole process.
Horizontal drilling is a process that's been developed commercially over the last 50 years in the oil and gas industry. In the UK's Bowland Basin, where shale gas rock is around 2 kilometres thick, it means that operators can drill at different levels of vertical depths within the shale layer. Contrary to popular belief, it's not carried out at right angles, but instead drillers can manipulate the drill bit from a vertical stance around a curve into their desired rock formation. One of the methods for horizontal drilling is to use a positive displacement motor with a small bend to steer the drill bit. The hydraulic pressure is used to drive the motor, which rotates the bit. At regular intervals, steering data is gathered and adjustments made to the well path. Horizontal drilling enables multiple subsurface wells to be drilled from one pad, which significantly reduces the visual impact on the surface and the environmental footprint.
So that video explains in some detail what you were talking about, Laura. I've just got one final question for you. You were talking about all the complex electronics in these pipes. How do you get the information to the surface?
Oh, that's such a good question, because it's so clever. As you realise, there's no wired connection between these tools at the bottom of the string and the surface, and the only things that are connecting us are the pipe and the mud column again. So there's no way of getting the signal up through the pipe. So what happens is all of the electronic signals are brought to a little unit called a pulsar, which, as you'd expect, produces pulsars. So it converts all the information about the azimuth and the inclination, and also if we're capturing information about the rocks we're drilling through as well, converts all that information into a binary signal like Morse code. And that little pulsar sends pressure pulses all the way back up through the fluid column to surface, up through the thousands of metres of pipe that we've got. And at surface, there is a decoder that receives those little pulsars and converts those back into the complex electronic signal as well, which the computers can then split out into the different parcels of information that they're looking for. And the system is so sensitive that it can detect about a 1% change in the pressure in the fluid to pick up that Morse code. And that's the way that they get all the information from the bit back up to the surface.
High-tech engineering just shows that engineering is indeed right at the forefront of technology and computers and everything else, as well as being out in the working environment. Laura, thank you very much indeed.
Thank you.
Well, Laura and I are now back, hopefully going to dodge the snow showers to answer your final round of questions. Lots of them coming in. Please do keep them coming in. And the first question is from Ruth, and she wants to get your response to concerns about the presence of sour gas in the Bowland Shale.
Oh, so that's an interesting question. So sour gas is a term that we use to describe gas when there's hydrogen sulfide in with the gas. Hydrogen sulfide is the gas that you'd associate with rotten eggs. So that has been found in gas reservoirs offshore in the East Irish Sea and across the globe. There's no indication that we have hydrogen sulfide. There's no indication that we have sour gas here in the Bowland Shale. That's both in this well and also the data that we've got from historic wells. So there's no sour gas here.
Next question, when will you be horizontally drilling and actually fracking?
So we're going to finish our pilot hole, we're going to take the logs, and we'll then start the directional drilling, and the horizontal drilling will be at the beginning part of next year. So yeah, through the first half of next year is when we're going to be doing the horizontal drilling and the fracturing operations.
The next question is about horizontal drilling. Now, this is the first site where there's been horizontal drilling into shale rock, but how much horizontal drilling has been done in the UK at all?
So it's a very well-established technique, primarily offshore. So in the North Sea, there are hundreds and hundreds of wells that have been drilled horizontally. Onshore, not so much, but there are a few examples of horizontal drilling, and actually in the UK where horizontal drilling was really breaking new ground. So there's a development down on the south coast of England called Witch Farm, which really back in the 80s when that was being developed really made big advancements in horizontal drilling technique and was able to access reservoirs actually from onshore, with then the wells going out under the sea in very environmentally sensitive areas. So it's well established.
Wireline logging has been mentioned in quite a few of these webcasts. And questions come in about that. What exactly is it and how do you use it?
So once we've drilled the hole, what we do is put down a tool, or what they call a string of tools, a number of tools on a thick wire, which is probably a 1-inch diameter cable, something like that, which is then used to measure information about the rocks themselves, about the fluid in the rock, about the well bore, and that information is then transmitted back up to surface via that wire and then recorded at surface. And that's to complement the data gathering in the well.
Next question just coming in, a fairly fundamental one really. How do you know that horizontal drilling is safe?
So, yeah, it's a broad question, a good question. So horizontal drilling has been conducted many thousands of times across the globe. So it's a well-established technique. I mentioned previously about the safety systems that we've got in place to ensure that the operation remains under control all of the time. We've got those mechanical barriers, the procedures and the training. We have constant monitoring of the well, from the tools that we've got by the drill bit to all of the surface monitoring that we've got here. So there's a long history of horizontal drilling being conducted, and then we've got constant data gathering to monitor and track what we're doing to give us a very, very high degree of confidence that it's perfectly safe.
A follow-up on that, I mean, what effect will it have on local properties?
Oh, none whatsoever.
Absolutely.
The well is about 6 inches in diameter at a depth of over 2 kilometres. So there will be no interaction between local properties and the wells deep below the ground.
A question about the well size. I mean, how big is it, and is it the same all the way down?
No, the well is a series of concentric circles, so it starts off at about 30 inches in diameter, and then the drain that we're drilling in the horizontal section is about 6 inches in diameter, and it steps down as we go deeper through the different formations.
Next question is about how far you're going to be drilling horizontally, and in which direction from here. I mean, Blackpool's over there and Preston's that way.
Yes, that way, towards
that way.
Blackpool. So the drains that we've got planned are about 1 kilometre long, and yes, we're drilling out in a westerly direction from this site.
A question about the mud tanks. They've got canopies over them now. Why is that?
Oh, a very eagle eye that spotted that. So, yeah, in the previous sessions we were drilling with water-based mud, and so if a bit of rainwater gets into the water-based mud, that's not really changing anything fundamental about the fluid. As we discussed earlier, we've now switched over to the oil-based mud that's helping us drill through the shale sections, and what we don't want is too much water going into that oil-based mud, because essentially we've then got to separate it out. It changes the fluid properties. So that canopy is simply to keep the rain off the tanks that have got the oil-based mud in them.
Well, let's keep talking about the rain and the cold and so on, because people are wondering how the recent poor weather has actually impacted on operations at all.
So the drilling operation is 24/7. That carries on regardless of the weather. But we have to, of course, make sure that as we're moving around the site, as we're operating, whether it's rainy or it's icy, that we do so carefully. Same sort of precautions you'd be taking if you stepped outside your front door on an icy day. We also have to make sure that we look after the welfare of the people who are working on the site. So we make sure that people have got comfortable offices to work in, that they're working, reasonable hours outside, that they're properly clothed for the weather. All these things, they sound like details, but that makes a really big difference, obviously, to the people who are here. So, fundamentally, we continue. It doesn't make a difference, but we've got to be mindful of the conditions that people are working in.
As we said on the previous question and answer session, you, as well as being a drilling expert, you're also responsible for the supply chain. And this is another question about that, and this is really from somebody with a very small business. How can they engage with Cuadrilla? I know you talked about how you're trying to make it reasonably easy for local companies to engage, but if you're really, really small, have they still got a role to play, and how can they do that?
It's exactly the same. So the methods are exactly the same. Register on the supplier portal. Tell us about the services that you can offer. Tell us about the goods that you supply. It doesn't matter how big or large the business is. What we need to do is make sure that the quality of the service and the goods that we procure is the same. So we operate with many very small businesses as well as very large businesses. As time goes on, there will be opportunity, we hope, in the long-term future of shale gas here for the whole of the supply chain to grow with the business. And we're already starting to build relationships with the supply chain here through the local chambers of commerce and various other routes to start to help local businesses understand what it means to supply into an industry that operates to such exacting standards. And that's a long-term process. But yes, the first step, get yourself registered on the supply chain portal, and if you are able to provide something that we were looking for, we will certainly be in touch with you.
Question now, we've got pipes beside us here. How long are the pipes?
So these drill pipes, they're between 12 and 14 metres long typically. That's the ideal size of pipe to be used with this kind of drilling rig.
Probably what might have to be our last question, how will you be monitoring the horizontal drilling as it goes on?
So we've got tools behind the drill bit that tell us where in space the drill is. We've got monitoring at surface, which is looking at all of the surface readings, so what the drilling fluid is telling us about the rocks that we've got, what the drilling fluid is telling us about the fluids that are in the formation. We get information about pressures. We get information about the way in which the well is responding. So there's all sorts of different monitoring operations. Those ones that I've just mentioned, they're obviously about the physical conduct of the well. But we're monitoring here on site for the whole range of impacts that my colleagues have discussed previously. So around noise, around light, around water quality. There's a whole array of monitoring to understand the operation and the impact that we're having within the environment here.
Laura, thank you very much indeed. And Laura said that it's a 24/7 operation here, and that does include Christmas. So an early happy Christmas to everyone who's going to be working here. Thank you all very much indeed for your questions. We'll be having another of these webcasts in February, so do keep in touch with us. And in the meantime, Merry Christmas and Happy Holidays.